Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today. Hello everyone and welcome to The Primary Loop. I'm Jim Anderton, Multimedia Content Director here at engineering.com. Self-driving, artificial intelligence, autonomous robotics. Now, engineers worldwide are working on a new generation of autos, seagoing vessels, submarines, and other devices that operate without direct human control. Now, the potential for harm if these systems are hacked is obvious, but how safe is safe? How can code be validated, certified, and tested? Well, these are important questions, and to help answer those questions, I'm joined by Dan O'Dowd. He's CEO of Green Hills Software. Dan, welcome to The Primary Loop.
Good to be here.
Now, Dan, you're a Caltech engineer with experience in hardware and software for NASA and, several important sort of high security programs in spacecraft, but also with Pentagon systems. You're probably better positioned than anyone to answer that basic question, which is, what are the risks for consumer devices which are now internet enabled but are broadly connected? How secure are these things?
Not at all. They have a very minimal level of security on them. They don't even meet the requirements that you see in big IT installations, which are being hacked all the time. It really is a matter of the quality of the data that they're going for. If it's not very important, then of course they won't spend the resources on it. But given that there are cameras everywhere and recording everything right now, there's a lot of stuff there, and it is very easy to get to. And consumer devices run from anything that's in your house, that's anything you can talk to, anything you can do anything complex with. It's listening all the time. It's recording and listening all the time, even if they tell you it's not. It has to be. How can it not know to respond if you don't? If you say something. So we keep going down that pathway, and that's on information. But on the other side, consumer devices like cars are a terrible risk because they're deadly. They if they fail, they can kill people. And systematic failures in those sorts of devices can cause large catastrophes, and so can hacking. Somebody could take control of a self-driving car. You say, well, they could hack a self-driving car, but since we now have over-the-air updates, so everything gets updated to new software very rapidly. So if there's a bug in one car, there's a bug in all those cars running that same software, which could be millions. And then they're all on the internet, so they can all be accessed by somebody, by a hacker of some sort. So now they can get into all the cars. Do something as simple as turn it to UK driving mode from US. Tells the cars to drive the wrong way on the wrong side of the road. Imagine 1 million cars suddenly driving the wrong side of the road all across the country. There would be millions of accidents in a matter of minutes, and tens of thousands of people, maybe hundreds of thousands, would die in those accidents because somebody found one way to hack one car. We need to have a far higher protection on the software than that and the security on that, which does exist. In the military, they have a much more strong security measures than are used in any commercial systems. And in the aircraft, there are reliability processes that people go through the software. It gets reviewed many, many, many times. At Tesla, they changed the braking software. They ship it to customers the next day. No, that's not. You can't do that. You have to test it for weeks and months. You want to test it in the Saudi Arabian desert. You want to test it in Nome, Alaska. You want to test it in a monsoon in Pakistan before you deliver it to hundreds of thousands of customers. Not the next day where you can say, oh, we fixed it, we made this improvement in one day. To me, that's horrifying, not comforting.
Dan, it's interesting you mentioned that. I come from the automotive industry myself, and for safety critical systems that are mechanical or purely electrical, the testing methodologies are fairly well known. I know that I can cycle a switch 2 or 3 million times. I can load it to 1,000% of its rated load, and I can be reasonably certain statistically then that if it passes that test, the production item will probably not fail within the projected lifespan of the vehicle. So there's sort of basic mathematical rules that we can use and statistical rules we can use with electromechanical systems to basically assure safety. But you're talking about a world where one single vulnerability is potentially catastrophic. I mean, could we potentially see acts of terrorism based on hacking things like self-driving cars?
Yes, and we will. It's not hard. There was a pwn-to-own contest a few months ago where it took 2 minutes to hack into a Tesla and get to the internal critical systems of it. People say that's not possible. It is possible. It is done. And for software, the same sorts of metrics and testing that exist for hardware. But they're not required in the automotive industry, and almost no one does them. And they just build it. They build it like Silicon Valley. They come up with some ideas, they write some code, they run it around the block a few times to make sure it works, and they do it. Now, there are some who are more responsible. I've seen some companies that do it very well. There's one company that has a complete driving system. They can go into their software system and say, let's test the new self-driving software on a drizzly day in April in the Alps, and they can simulate that experience and run the software through that experience, which is a responsible way to do things. But there are many companies that do things terribly irresponsibly, Tesla being the worst of them. They just develop it like they do in Silicon Valley, like they do software in Silicon Valley. Write the code, test it a bit, and put it out there and let people drive it, and then wait for them to complain.
Dan, code is stunningly complex these days. Tens of millions of lines of code, common these days at this point. Are these systems at a level of complexity? Well, I guess what I'm really asking is, can they in fact be extensively tested with just the simple amount of code that we're talking about here in a reasonable time frame?
Well, that part of it is about how you write it. And if you build aircraft software, what they do is they divide the software into 5 categories. Level A is if it makes a mistake, the plane could crash. Level B is if it makes a mistake, then could cause some serious problem in the system that could lead to people being hurt or injured. And you go down to C and D. And when you get to E, that's the entertainment system. Nobody cares. That's where the tens of millions of lines of code are. The amount of code that's actually flying the plane is vastly less than that, and developed in a far superior methodology with a lot of review. Every line of code is reviewed at least 10 times. And by our engineers, by our tech engineers, our customers' engineers, the FAA's engineers. They often even bring in competitors. If you're doing a Boeing project, they bring in Lockheed guys to look it over just in case, everybody's working for the company, and the other guy, the Lockheed guys, are working for a different company, and then maybe they'll find things that somebody won't. So that whole thing, it all exists in software. It just doesn't exist in this new area of software, which is the hundreds of millions of lines of code, not the relatively simple systems that can be very well tested. But if we divide it up correctly, can this software crash the car? Now we should spend a lot of energy on testing that. If this is the entertainment system, that's not a big problem. If it's the speedometer, that is a safety critical thing, but you can drive without a speedometer. I mean, that's intermediate. That's not the highest level, but it's not the lowest. And you do it, so you design your system, you discover, you analyze what parts are really critical, and you do the parts that are really critical very carefully. That's what we should do. But they're not doing it.
In mechanical systems I'm familiar with, part of the SPC, part of the quality process is determining what the minimum information set is, the minimum data set that you need to accurately determine the reliability of the system that you're working on. And ideally, in a perfect world, you want that literally a minimum data set. Every measurement carries uncertainty, and of course, you could end up with an infinite by infinite matrix if you try and measure everything. So part of the challenge is to figure out how small a data set can you use to actually get some certainty here. Yet code is something which seems to allow almost unlimited complexity for free. I mean, basically, are these systems too complex for what they're asked to do you think?
For the safety question, the answer is no. It's not too complex if you do it right. If you segregate the software that's safety critical, which is not that much. Most of those lines of code, if they fail, people won't die. It could be inconvenient, it could be annoying, but for the most part, it's not. Especially, actually, an important process is human override. You need to have a human override in your systems in case something does go wrong, and you can take control. There's the big AI debate. there's a second component of it, which is it isn't even really AI. But if we put the computers in charge of all these decisions without human interaction, then when a human says no, these things are not going well. You need a button on your dash that's a mechanical button. It doesn't have any software behind it at all, that disables the self-driving computer and gives you back your control as a driver. So when something bad happens, you can do it. The same should be true of any dangerous device. In the power plant, there still needs to be a big mechanical switch on the wall that when you pull that thing down, it electrically disconnects the systems. Not I push this button, it turns that off. What if that software running that button fails? There's no way to turn it off, and the power plant melts down because nobody could run into the room and pull the switch that just shuts it down. Okay, we're going to shut it down. We're going to figure out what's wrong. Maybe we'll bring it back up, but we can keep it from melting down. Human in the loop is critical to all these safety systems.
Dan, I know that Garmin has introduced an Autoland system designed to allow single pilot operation of jet aircraft, light jets in this case in particular. And it's sort of literally what you're talking about, a panic button in the passenger cabin, which when depressed by a passenger would then allow the autopilot system to literally take control of the aircraft in case of pilot incapacitation and fly it safely to a safe landing, at the nearest available airport. But that's the opposite of what you're talking about here. That's a situation where the software, in a sense, is the fail-safe to the human system, not the other way around. So it sounds like what you're arguing here is that you literally need a knife switch. You need a sort of some device in which you can absolutely and resolutely kill software intervention and take control of the steering wheel. So does this mean that in the future, the self-driving car will always have a steering wheel and conventional controls, do you feel?
Well, if you can get it reliable enough that it never happens, or it happens so way less than it does with humans, then you can go forward once you've proven it out. But we're nowhere near that today in terms of reliability. The average driver is 20 to 30 years between accidents. That's hundreds of thousands of miles between accidents. The best out there in self-driving cars are things like Waymo and Cruise. They're at 10,000 to 20,000 miles between human interventions, necessary interventions. Good human drivers and average human drivers are up in several 100,000. Then you have your laggards like Tesla, which are at 10 miles between interventions on city driving. And they don't have any concern at all for that level of reliability.
Dan, one last question is that with current hardware technology, with our current strategies for coding, is full self-driving at the levels of reliability you're talking about possible with the current technology and our current knowledge as it stands today?
Yes, I believe it is possible. We are not there. Some people, quite a few people actually, there are real driverless cars now, right? In San Francisco, I'm told if you stand on a street corner, you'll see a driverless Waymo or Cruise drive by in a few minutes. A friend of mine just sent me a photo yesterday. He lives in Los Angeles. He sent me a photo of a driverless Waymo because they're now testing in Los Angeles. So those are real driverless cars. They haven't yet quite reached human level of safety, but they're getting there, and I think they'll get there in the next few years.
Dan O'Dowd, CEO, Green Hill Software. Thanks for joining me on the program.
Thanks for having me.
Well, that's it for this episode of The Primary Loop, brought to you by engineering.com. For our deeper engineering series, visit engineering.com TV for exclusive shows like Manufacturing the Future, Designing the Future, and the Engineering Roundtable, not found here on our YouTube channel. The links are in the description below. Thanks for watching.